In this video I'm going to talk about the sum of the first n Fibonacci numbers with odd indices. So the Fibonacci numbers are defined like this recurrently. So first we set the first two Fibonacci numbers to 1, and then we have the recurrent relation that says that the next Fibonacci number is equal to the sum of the two previous ones. So in one of the previous videos I proved the identity that the sum of the first n Fibonacci numbers is equal to so the identity was like this: f1 plus f2 plus and so on plus fn is equal to fn plus 2 minus 1. I think that's how it looked. But in this video I'm going to prove another identity that involves not the sum of the first n Fibonacci numbers, but the sum of the first n with odd indices. So not from like f1 plus f2 plus f3 plus and so on, but f1 plus f3 plus f5 and so on plus f2n minus 1. So the proof is going to be by induction. So by induction. So the base case for n equal to 1 is easy. So on the left side we have f1, and on the right side we have f2, right? So, and of course this is true because both of them are equal to 1 by definition of the Fibonacci numbers. So this is true. Okay, so the base case holds. So now let's do the induction steps. So we suppose that the identity is true for n. Suppose that it is true for n. Consider it for n plus 1. Consider it for n plus 1. So what we have for n plus 1, so let's rewrite it. So we have f1 plus f3 plus and so on plus f2n minus 1 plus f2n plus 1, and we need to prove that this is equal to what? To f2n to f2n plus 2, right? So let's rewrite the left side. So we start with the left side. So we have f1 plus f3 plus and so on plus f2n minus 1 plus f2n plus 1. So the first terms, like, so all the terms except the last one, we group it together, and we notice that this is exactly the expression in the left, like on the left side in the inductive hypothesis. So we assume that this equality is true for n. So by inductive hypothesis we write that this is equal to, so this is by inductive hypothesis this is equal to f to n plus f to n plus 1. So the last term we leave it as is. Okay, and now we notice that this is the sum of the two consecutive terms. Let me write this more carefully. Okay, so this is the sum of the two consecutive Fibonacci numbers by the original recurrent relation. This is equal to the next one. So this is equal to f to n plus 2, right? And this is exactly what we need to prove. So this is equal to the right side in the equality that we need to prove. So we started with the left side and we arrived at the right side. So this basically concludes the proof.